Hello, this is Ron Hardwig. I've talked to you before about tornadoes, how, why, when, and where they form, what are their source of energy, and why do they dissipate. As I mentioned, my name is Ronald Hardwig. I'm a professional engineer, not a meteorologist, and you can reach me at rsdatainc@aol.com. I'll put this back up again. I have a couple other sheets. But what I want to talk to you today is even more important than what I've talked to you before. I want to talk to you about how to know, does the tornadoes, are you the target? Are you the target of a tornado? How to know in advance, days in advance, if you're going to have one in your area. Once again, my name's Ron Hardwig, and you can reach me at rsdatainc@aol.com. Now, we know a tornado forms within a thunderstorm. A thunderstorm starts the process by the warm air coming in from the Gulf, overriding the cold air coming down from the north. You get a circulation. As that circulation continues to go, if one of the ends is turned upright, we have a vortex. Now that's all formed within the thunderstorm. That's fine. But that's as far as it goes for the thunderstorm. It takes the jet stream to turn that vortex into a tornado. And it does it in this way. As the jet stream passes over one of the vortexes that is formed within the thunderstorm, there's a slightly lowered pressure due to what's called the Bernoulli principle. If your mother had an atomizer where she sprayed out perfume, you had a little bulb that you squeezed, that air going at the top of with the tube down into the perfume, sprayed out a little bit of perfume along with the air. A tornado is working in the very same way. In this case, though, instead of a bulb, we have the jet stream passing over the top, slightly lowering the pressure of the vortex that was formed within the thunderstorm. But it takes the jet stream to turn that vortex into a tornado. Now, as we know, the tornado fully formed comes all the way down to the ground. The action, Newton's third law of motion is for every action there's an equal and opposite reaction. The action is actually up here. The slightly lowered pressure over a very large area comes down to a concentrated lowered pressure, very much lowered pressure down on the ground. It's all concentrated down on the ground. It's working just like an atomizer. Just to give you an idea, if the jet stream was down here, where the diameter of the tornado was 10,000 feet, or roughly 2 miles, and you had just 0.001 pressure drop, just 1,000th of a pound pressure drop at this, it would equal a 0.625 pound pressure drop down here. Or in other words, you would go for, if you had a normal pressure of 14.9, it would go down to 14.275 pounds down here. And that's enough. I heard the other day where somebody had said they had parking blocks pulled up off the ground in a tornado. I couldn't believe it. But I did some calculations on it, and yes, it would. That would be enough pressure differential with only 14.275 pounds pushing down on the top, and around the side, you had 14.9. It would lift it off the ground. Now, I'll keep this up here. This is what this is all about. How to know if you're the target of a tornado. How to know days in advance and watch it. Now, I've looked at over 1,400 tornadoes. A lot of them in mass where we had outbreaks where we'd have 126 tornadoes in one day. One thing they all had in common, they happened under where there was a high-speed jet stream overhead. Unless you have a high-speed jet stream overhead, the thunderstorm is not going to create a tornado. It takes the jet stream to create the tornado. And this plot here pretty much shows that. What I did, I plotted 10 EF1, 10 EF2, 10 EF3, 10 EF4, and 10 EF5 tornadoes. That's on the Fujita scale. If you notice, the ones are here, 2s, 3s, 4s, and 5s. And what I did was plot the velocity of the jet stream where these tornadoes happened versus the height of the jet stream where these tornadoes happened. And you'll notice two things. The higher the jet stream, the stronger the tornado. This way, the higher, and the higher the velocity, the stronger tornado. Your stronger ones is where you got the highest velocity and the highest height. The height comes into play, as I said over here, due to the fact that a tornado fans out. Every time the diameter doubles, the actual area quadruples. Now this is straight the diameter or the area of a circle. It's just pi r squared. But every time the diameter would double, the area quadruples. Once again, from 40,000 feet to 80,000 feet, it would quadruple again. The area would be 4 times as great as here. So that's how the height comes into play. Now, in my research and doing this and plotting these, some of you will notice the Moore, Oklahoma tornado just this past year, 22nd of May, 1913. The Washington, Illinois tornado, which my daughter was just missed by 1 block, and that's one of my reasons for getting this research out. The Gerald, Texas tornado, the Plainfield tornado, and of course the Joplin, Missouri tornado that we know of. You'll notice that the velocity wasn't that high for the Joplin, Missouri tornado, but it was high. So that meant it fanned out. It had more relative area of interface, so you had a stronger tornado on the ground. Now these are what is actually, they go out afterwards and they determine by the damage if they want to call it a 1, 2, 3, or 4, or 5. So you will see some intermixing in the 4s and 5s, the 4s and 3s, the 3s and 2s. You'll see some mixing because it's all subjective how they look at it. Now one thing I didn't even know this would come up. I found that you have what you call a tornado threshold of about 58 knots. That's why not every thunderstorm has tornadoes. They always try to figure out why only 20 to 25% of the thunderstorms have tornadoes. That's because only 20 to 25% of the thunderstorms are developing under a jet stream strong enough to develop the tornado, which is what this whole thing plot shows. If the jet stream is below about 58 knots, all you have is hailstorms. In order to have a basis, I looked at 10 hailstorms where we had large hail. I'm talking 2.5, 3 inch in diameter. And you'll notice we didn't have any tornadoes up to about 58 knots. You'll notice 1, 2, 3, 4, right here, right below. And then we got 1, 2, 3, 4, 5, 6, 7, just above. And they had tornadoes. This proves you have to have the high-speed jet stream overhead to create a tornado. That's what's been missing. That's the missing part. Now what I'm going to show you here is how to know if you're in the area where a tornado might be. Of course, you can go on to www.weather.com. You can see what the forecast is for your area as far as thunderstorms. Or you can go on to the SPC NOAA site and get on there. Now, I actually will have this. If you want to email me at RSData Inc., I'll give you a step-by-step procedure of how to look for your area to know if you're going to be in a tornado. If there's a thunderstorm forming in your area, the first thing you want to do is go to this next website here. It's at San Francisco State University. I'll put this up and let you see it. But if you go on that website, you'll come up with maps like this. This is a jet stream maps, and it shows that there was a high-speed jet stream going over Missouri, Illinois, and up to the northeast. And actually, it gets higher up here. It gets in the 70 to 90 knot range up here, where it's only down around 50 and 60 down here. Now, just by chance, I was putting this together Wednesday evening now, and I pulled this one up that was from Tuesday evening. And if you remember, they had a tornado hit up there and 4 people were killed, 1 little baby. Now, as I was writing this article, before I even knew that, I said, if you would happen to live in the Northeast, you would want to be watching out because you could have a tornado in that area. And lo and behold, they did have one. But you go on this site, that's the one at San Francisco State University, this website here, and you can look up these jet stream maps. Now, these maps are at what they call the 300 millibar range. Now, that's really a pressure range, but it happens to come out, it's about 32,000 feet or around 9,400 meters. Now, this is the only ones that they plot specifically. The problem is, not all tornadoes are right at 32,000 feet. A lot of the stronger tornadoes are up above 40,000 feet. As you can see, here's 40 here, here's 45. That's where you get your bigger tornadoes. So, this is a check. You can go onto this site and actually can look up where they expect the jet stream to be up to 5 days in advance. And it'll show you where it's going to be about every 6 hours if you go on that site. And they'll lead you through how to go through that. Or as I said, if you email me, I will give you step-by-step instructions. Now, as I said, this is only at the 32,000 foot range. But what about the other heights? Well, there's another site that you can go on to. That's this one here at Wyoming, University of Wyoming. If you go onto that site, you can check out all the weather stations throughout the United States, Canada, Alaska, down into Mexico. And what they do balloon launches 2 times a day, normally around noon and normally around midnight. Now that's Greenwich time, so you got to understand that. And if you go on my website, I'll tell you how to handle that too. But you can go onto these sites. If you lived in St. Louis, you'd want to look at Springfield, Missouri. You might want to look at Topeka, Kansas. The jet stream always comes down from the west and goes to the east. So you're going to want to look west, or southwest of where you live to see what the jet stream is doing. Now this is just a blow up of that with the United States, and it can show you where the different websites are. There's Albuquerque, New Mexico, Denver, Colorado, Rapid City, South Dakota, Bismarck, North Dakota. But you can go on those sites and see what the jet stream's doing. Now, when you look up the jet stream there's more than, I think, about 10 columns, but you're going to be interested in the second column, which tells you the height in meters, and the 8th column, which tells you the jet stream velocity in knots. And you're going to want to notice if that jet stream is anything above 58 or 60 knots, and that's above where you live, you want to be looking out for a possible tornado if there's thunderstorms developing in your area. Now, when you go into that column, looking at this weather at Wyoming, look down the height column, or the velocity column, excuse me. Look down the velocity and see where it peaks out. When I looked at the other day, at the one where the tornado was over New York, I looked at the one in Buffalo, New York, and they had a jet stream that topped out around 103 knots, up at around 12,500 meters, which would be 41,000 feet. So it was up in this area. Now, they classed it as a Class 2. It might even been a little higher, because that's just what they thought it was on the ground. The main thing is, the main point I want to get out is you can be watching yourself. The meteorologists are not doing this at this time. I wrote an article for the American Meteorological Society, but they didn't think the article was good enough for their magazine. They didn't say my research was bad, they just figured it wasn't good enough. I feel very bad about that, because if I'd had it out, these people in New York would have known. So, tornadoes. Are you the target? How to know. Tell everybody. Tell your friends. I hope I'm swamped with emails trying to tell you what I have set up. I have a step-by-step procedure. These are the 4 weather sites that you go to find out all the information. The first 2 tell you where the thunderstorms are forming. The last 2 tell you what the jet stream's doing overhead. And you want to be looking at that. The very last one here, rsdatainc@aol.com. That's my email address. If you email me, I have this set up on a step-by-step procedure, how you can watch your area and know if a tornado is going to be in Europe. You'll know 2 or 3 days in advance. Now, you might not know that it's going to be within 200 or 300 miles of you, but as you get closer to the day, if you know there's a high-speed jet stream over your town, and then you see that there's a thunderstorm, a big thunderstorm forming there, you'll know even before they announce there's a tornado that there's going to be one in that area. That's what I'm trying to get apart. So once again, my name's Ronald Hardwig. You can reach me at rsdatainc@aol.com. I will send you instructions on how to do this. And if anybody would like to have my report, was about a 28-page, I'll email that to you too if you ask for it. Once again, the thing is, are you the target? How to know. My name is Ronald Hardwig, and you can get to me with rsdatainc@aol.com. Thank you. This is a clear view of the websites that I've been talking about. www.weather.com, you can get where the thunderstorms are, or http www.spc.noaa.gov. Those two give you where the thunderstorms are. The last two, San Francisco State University and Wyoming, give you where the jet stream is. And if you want to email me at rsdatainc@aol.com, I will give you step-by-step instructions. Thank you.